Differential thermal analysis. Thermal analysis techniques. When a material is heated, its structural and chemical composition can undergo changes such as fusion, melting, crystallization, oxidation, decomposition, transition, expansion, and sintering. Using thermal analysis, such changes can be monitored in every atmosphere of interest. The obtained information is very useful in both quality control and problem solving. Types of thermal analysis: TG, DTA, DSC. In differential thermal analysis, the temperature difference that develops between a sample and an inert reference material is measured when both are subjected to identical heat treatments. The related technique of differential scanning calorimetry relies on difference in energy required to maintain the sample and reference at an identical temperature. Thermogravimetry. Thermogravimetry is the measure of the mass of the sample as the temperature increases. This method is useful for determining sample purity and water, carbonate and organic content, and for studying decomposition reaction. Introduction. This is a comparison method. Analytical method for recording the difference in temperature between a substance and inert reference material, such as a function of temperature or time. Any transformation, change in specific heat or an enthalpy of transition can be detected by DTA. In DTA, both test sample and an inert reference material controlled heating or cooling programming. If zero temperature difference between sample and reference material, sample does not undergo any chemical or physical change. If any reaction takes place, temperature difference will occur between sample and reference material. A DTA curve can be used as a fingerprint for identification purposes. For example, in the study of clays, where the structural similarity of different forms render diffraction experiments difficult to interpret. This is a plot of furnace temperature versus DTA signal. Sharp endothermic, changes in crystallinity or fusion. Broad endotherms refers to the dehydration reaction. Physical changes usually result in endothermic waves. Chemical reactions are exothermic. Apparatus. The key features of the differential thermal analysis kit are as follows: sample holder comprising thermocouples, sample containers and a ceramic or metallic block, furnace, temperature programmer, recorder system. Heart of the analysis: heating block. Identical pair of cavities for the sample reference material. Whole unit is set in an oven, control pressure. Thermocouple is placed directly in contact with the sample and another in contact with the reference. Temperature of the block is raised. The temperature of sample and reference follow. Zero temperature difference, no physical or chemical change. If any reaction gives difference in temperature. This is a graph between temperature and temperature difference, and here is a figure of DTA instrumentation. Differential thermal analysis. The advantages: instruments can be used at very high temperatures. Instruments are highly sensitive. Characteristic transition or reaction temperatures can be accurately determined. Disadvantages: uncertainty of heats of fusion, transition or reaction estimations is 20 to 50%. Factors affect result in DTA: sample weight, particle size, heating rate, atmospheric conditions of sample packing into dishes. Factors that influence DTA curve: heating rate, effect, change in peak size and position. Suggestions: use a second, location of thermocouple, a reproducible curve. Suggestions: standardized thermocouple location. Third, atmosphere around sample. Effect, change in the curve. Suggestions: inert gas should be allowed to flow. Fourth, amount of sample. Effect, change in peak size and position. Suggestions: standardized sample mass. Particle size of sample. Effect, irreproducible curves. Suggestions: use small uniform particle size. Packing density, irreproducible curves. Suggestions: standardized packing technique. Seventh, sample container. Effect, change in peak. Suggestions: standardized container. Applications: Quantitative identification and purity assessment of materials are accomplished by comparing the DTA curve of sample to that of a reference curve. Impurities may be detected by depression of MP. Thank you.